Okay, the first equation is fx equal to x to the power of 5 minus 10x to the power of 3. So the first step is we must find the x-intercept, where fx equal to 0. So from the equation, we equate to 0. So we simplify the equation. X squared minus 10 bracket x to the power of 3 equal to 0. So squared minus 10 equal to 0. X squared equal to 10. X equal to plus minus 10, where x equal to 3, x to the power of 3 equal to 0. X equal to 0. So in the point form, it will be like negative 10, 0, 10, 0, and 0, 0. Okay, after we find the x-intercept, we will find the y-intercept. So where x equal to 0, therefore we substitute the value of x into the equation. So it will be given like this. So f0 equal to 0 to the power of 5 minus 10, 0 to the power of 3. So we calculate and we get f equal to 0. So in the point form, it will be like this, 0, 0. Okay, next we will find the critical point. So where f prime x equal to 0. F prime x is the differentiate of fx. So the equation given is fx equal to x to the power of 5 minus 10x equal to 10x to the power of 3. So when we differentiate, we get x to the power 5x to the power of 4 minus 30x to the power of 2. Then we simplify it, so it's easier to us to calculate. So we get f prime x equal to x to the power of 4 minus 6x to the power of 2. Then we will equate to 0 like this. So we will get x to the power of 4 minus 6x squared equal to 0. Then we simplify it again so that we can calculate the x. So we simplify x squared minus 6 in bracket multiple by x to the power of 2 equal to 0. So then we calculate the x. So yeah, like this. And then we can get x plus minus 6 and x equal to 0. Then in the point form, it will be like this. Okay, next, we must find the interval of decrease or increase of the equation. So we will do a line so that we can easy to plot it. So this is the line where this is the point. This is critical point where we got from the here. So then we will use the f prime x equal to x to the power of 4 minus 6x squared to find the interval between this. So that negative 6 is between 2 point, let me check the calculator, negative 6. So we got 2.449. So we must select a value between the value. So I choose 1 and 3. So here will be negative 1 and here will be 3. So we will substitute the value that I choose to the equation so that we will know where the line is positive or negative. So f prime 3, negative 3, f prime negative 1, f prime 1, and f prime 3. So we insert the equation to the calculator and substitute the value of givens. So when we substitute negative 3, we will get 27. So it is positive. When we substitute negative 1, we will get negative 5. So it is negative. And when we substitute 1, we got negative, also negative. And when we substitute 3, we got positive. So when we got the value, so in this line, so we will do the border here. So we will know where we want to put it. Okay, so there are 4, 1, 2, 3, 4. When negative, it will upward. So like this, negative, downward, negative also downward, and positive upward. So we'll know the interval of increase or decrease where it will go. Okay, then number 5. Sorry, okay. 5, we will find the local minimum or maximum. So in this case, as we will see, the critical point is 0, 0, and for the first step, we also get 0, 0. So there is no local minimum or maximum since the point 0, 0 is at the center. Point number 6 is where we will find the inflection point, where f prime x equal to 0. So f prime x is where we differentiate the equation twice. So as we know, the f prime x is x to the power of 4 minus 6x squared, and so for the f prime x, we will get 4x to the power of 3 minus 12x. So we simplify, so we get x to the power of 3 minus 3x. So we will keep equal to 0, so equal to 0. So we simplify to get the equation. So x squared minus 3, x equal to 0. So x squared minus 3 equal to 0. X squared equal to 3. X equal to plus minus 3. So for x equal to 0. So in the point form, so we will get negative 3 and 36.3731. 3, 36.3731, sorry, negative. And here is 0, 0. So if you are wondering where I get this value, so this value of x I will substitute into the first equation that we get. Okay, next is we're using concavity test for find. We will use same method as before, where we're gonna use the line, so it can easy to figure out. So in the orange highlighter is the inflection point before, and in the green highlighter is the test point we will use to find the concavity, which means it's upward or downward. So we insert the test point into this formula, this equation, and then we got like this, where when it's negative 3, we got negative 18, which is negative. When the negative is we concave downward. So at here, this is concave downward. So when negative 1 is inserted, we get positive. So it's concave upward, and this will repeated as this. Okay, from what we get before, where is this? So we insert this increase and decrease to that graph. So this graph, so it's like up, down, down, and up. So as we know, this is concave downward, so it will be like this, concave downwards. Upward, so it will be like this, downward, and upward, okay, like this. So after we determine the concave up or down, we can plot the graph. By using this point, the inflection point, we will plot it into the graph. So we have negative 3, 0, 0 here, and 36.3731 here, and negative 36.3731 here. So this is a y, and this is x. So we will plot here. So assume it's here, it's here, and it's here. Okay, so where we know where is the turning point, here, and here. Now we will plot the graph. So after we put the point, so that this first is concave down. So we know the turning point is here, so it's concave down. This is concave upward, so to the 0, so like this, and this is turn downward to here, and it will go upward. So it's like this. So this is the graph where we form.